Let's see if we can clean this up a bit. This is 100% acetone. And the secret here is just your patience, because eventually the glue will dissolve. It can take a while. You can see, if you're lucky, it starts to peel off, and then it becomes easier. And I try to avoid using metal tools too close to the board, because it doesn't look good. So let's start. If you have strong nails, that's a plus. His nails won't do any damage to the board. It's better than plastic. I may have to let it sit with. Oh, that's the right relay, by the way. Right here. I don't understand why people don't buy the right relays, because they're just drop in. They don't need to have any adaptations or anything. They just go. In this case, it's a different model of a different version of the board, and so you need to cut 2 pins from the relay. I'll show you in a minute. As I said, this is one of the things that are not hard, but takes a long time. But I just don't like to leave too much glue behind. There's some places where you can't really touch, but otherwise you're gonna have to strip the whole board out of components, which is possible. But you're making hopefully informed choices all the time. See what works best. Sometimes you make a little bit of compromise. But as you can see, the acetone will dissolve this thing pretty good. The other thing I try to never do is remove the wires from the board if I can get away with it. I don't know. I never had good luck putting it back together, and then you get hung from somewhere you don't know where it is, and a lot of times it's from factory ground that you mess with. So I try to leave it alone. Okay. Almost there. I'll come back a little later with and put some more acetone in this area, because it's getting, you see, it gets under the resistors, under those components and stuff, and Meanwhile, I'm gonna go and work on those two transistors here. So, be right back. Alright, so let's remove those two transistors. Some people that I respect a lot at Audio Karma recommend that we replace those transistors because they're barely within spec. And this is a big amp, so you want to give it as much juice as you can provide. You're always gonna have to be careful with the sequence of those things here that go in the, and put them in the right sequence. May not sound very important, but I like to put them because they give the proper contact, and that's where the collector is, but that's where most of the current is. So as you can see here, it's the nut, a flat washer, and a star washer that gives contact with the board. And then on this side, you have another, a little thicker round, those, I think that's the one that has a slit in it. I don't know, but yeah, you gotta be careful just not to lose it. It's very easy to forget or to overlook. So you have to, ideally you put those things on a bin somewhere where you can remember where it came from. So yeah, so those are the two original. Most people don't change them, but I do. Then I'll replace those mica pads, and use this time to clean it up as good as you can. Sometimes you think you can't clean it, but what happens is with time you can see some heat stress on this heat sink, and when you put an MGE 15032 like these, those guys are heavy duty and they can last forever, and they're not gonna get as hot. So just clean up, make sure it gives you a good contact when we put a new mica, a new thermal paste. And then we use this time to, just do some cleaning. I don't strip this thing bare to the chassis because it's way too much work and not really necessary. But you can clean the areas that you're able to reach, fairly easily. And in some models, you don't want to sand it anyhow because it may have cadmium. You gotta be very careful with the materials that people use to build those things, because quite a few things may be poisonous. So let's see. So those two guys here, you got the center pin. We're not gonna use it, and this is the collector that ends up connected to the back of this anyhow, and then it gets connected through the screw that goes through it. That's why it's important to have a good connection. And there's another thing that I like to do. May sound like overkill, but I like to get some shrink tubing and slide it up the transistor legs. This is more like in some sort of insurance, if you will, that you won't be risking those legs to touch the heatsink at any time. And here's the, I don't like, well, I used to like the seal pads, but I know from good source that there is nothing better than Seal 340 for those. You just spread a thin layer, try to be as clean as you can. And we'll clean it up later. So here's the proper bed right there. And a tube like this is gonna last you for years. It's very expensive, but all in all, performance-wise, it's the best one out there. Some people use Wakefield. I started using Wakefield when I was beginning to do this, but again, you meet people along the way that give you better options. So try to be very gentle and put it in there. Best to find the holes there, right there. Okay, and we're gonna get a Q-tip and clean up. So there's the other one. And then we get a little bit of a, oops, I have no idea where that went. Since this is non-conductive, I don't really care, but you don't want, if you're cutting wires, and you got to be careful where the wires go. You don't want them to land on a board somewhere. So another one on the back. Yeah, just take your time. That's something that people may not realize. It's not that it's complicated or hard, it's just that if you want to do it one time, want to do it right, you gotta do it slowly. So a board like this can take more than an hour to get done. Now try to figure out, an hour of labor, how much would it be worth in the marketplace? And then you try to extrapolate to other boards that are more complicated than this, because the power supply is pretty straightforward. You just, if you just don't, you don't want to mess it up, because you can it can cause all kinds of problems. So you want to make sure it's done right, but at the same time, it's not that complicated. So we're gonna put the right sequence, the screw with that spacer, and then this star, and then the flat washer, and then hold it with the there's something that I wanted to do but I didn't yet, is to get the blue product to set the screw, because it keeps it in place, but it's very reversible. You don't want to over tighten it. It just needs to be just right to get the right connection, but you don't want to cause any undue stress or, God forbid, damage the board. So then again, the star and the flat and the nut. Tighten it a little bit, then come with the. By the way, you want to use one of these. This is a JIS screwdriver because it fits the Japanese screws better than anything. This is not Phillips. Not too many people realize that. All right, so those two are in place for when we want to come back and solder, but they're where they need to be. So I got my my cotton going here. Just gonna try to remove some more. As you can see, acetone does a pretty good job of loosening up, and I don't want to go too deep under those resistors because they can break, and I don't know if I have all of them. It's really complicated to have stock of every possible resistor at the different values, etc. There are some resistors that we know that we change all the time that I have to have in stock, but those small values, those guys, the original ones, they pretty much never go bad. Those guys, they're excellent quality. Sometimes you see a large carbon comp that may be worth replacing, but it's not always, you know. So as you can see, the board is not much better than it was. Let's start making some comparisons. Like we had a 470 microfarad 63 volts as the big one right there, and we're going to replace it with 1,000. We could go 1,200 if I wanted. I don't have it. Place it there, and then let me put this away. And now those two guys here, that used to be the 220s there, and we're going to beef it up quite a bit trusting some folks at Audio Karma that calculated this and swear by it, that it gives better results. So this is a much beefier. Gotta be very careful with the orientation. So positive is there, negative is on this side. Right there. And again, I'm not gonna glue those things in. What else? Just a second. So then again, this is a much beefier here to get a better smoothing of the regulated supply. I try my best to use good quality, low ESR, high temperature components here, because the power supply is extremely important for the final sound. So if you feed the preamp well, then you're gonna have good results. So that's another one that goes there. I think there's a 22. Yep. That goes on the back. You gotta be careful because not all capacitors can be upgraded. Like if you have it on the timing circuit, it changes the timing constant, and it may take longer for the relay to kick in, and you don't want that. Go to 22 there. 220. 35 go there, and then 4725. And so what did we used to have here? So like here it was a 4716, we're just 4725, a little more voltage, but again the same same capacitance, because it's part of the oh, here's something interesting. This is a 220. I think that's what the manual calls for, but we had installed here at 330, so I may stop now and get another 330 here, because who knows, this works in combination with some resistors, and if it's a different version of the board, you may have a different resistor to do the time constant. So I'm just gonna follow whatever we had here because it's kind of critical. So you know, sometimes you gotta be careful. You can't just follow what you find on the web or even the manual. You're gonna have to really pay attention to what was installed originally, and in many cases you cannot even trust the markings on the board if you're lucky to have them, because like there's some other older Marantz that didn't have any markings on the boards, and that can be a lot of fun. So now let's put in a new resistor. Like this is the original 5 watt, and this is a newer 7 watt, and almost the same size, and it'll give you a better performance. So it's not gonna get as warm. It does get pretty warm, but it helps. That's the thing, you know, when you do restorations, is small increments of things getting better make a difference at the end. You know, there isn't like one big thing that you can say, hey, this has made all the difference. It's a lot of small increments that you go through. Now, let me just make sure that those are the double diodes that are going to replace those two guys here. You know, not that they're bad or anything, but those make a big difference in the noise floor. That's when you turn it on and you have no idea if it's turned on or not. That's my always my one of my goals. So they don't quite fit exactly in the board, so I'm gonna have to kind of carefully bend the legs so that they will hopefully enter like straight into those holes. And this is nice because it doesn't really matter what direction that you go with them, because it will, you know, backwards or forwards, it's the same circuit. It's a dual diode. I think the original one actually has the picture of the diode on top of it. But you can also see here on the board that that's the marking of the negative door towards the common. So it's common. And you know what I know what I think it is? And those guys are expensive, like relatively speaking, but they're worth it. They're very much worth it. I never regretted installing them on any, doesn't matter how expensive or how big the receiver or amp is, it's always worth it. And the older receivers, I use ultra fast, but just normal single diodes, like the T270 takes 5 of them in the power supply. So the fact that this is the way it was done in factory is just sticking out like that. It's easier to remove, but it's a little more involved to put it back, because when you turn the board over, the component may fall. So there's a little bit of technique that you can use to have them properly in place. Now we're gonna replace this that was there. It's too bad that I don't have like an original to show. With this is a drop-in MY2, so you can see here that that's the circuit that goes to the inductor that will create the magnetic field, and then it's going to connect this side to that side using this. So it connects this thing with this thing, and this is where the output goes to the speaker posts. And when people talk about, oh, how thick does my speaker wire need to be, I just show them here, this and here, say, hey, look, that's how it is inside. This is like what, 22? Of course, it's short, so this one you need to cut those 2 pins that are not used, and make sure you put them in the right position. So that's the board pretty much populated. I'm just gonna go there and get a transistor to replace here. Be right back.
So this is a much beefier transistor than the one that comes installed. This is a C734, and I don't know. It's one of those things I like to replace whenever I can. Sometimes I replace the ones in the protection. Those are not stressed as much. So just bear with me because now it's going to be fun.
So let's begin with the relay, which can be a bit of a challenge. So what I do, I get a little bit of solder on the iron just to get started and have it like have a place to, something to keep it in place, if you will. And then I hit the other ones, the other pins, and I'm try to be pretty liberal with the solder here. Make a very nice contact, as you can see. But don't stay here for too long because those pads, they come out, and I don't like when that happens. And I try to be like random where I go so that it doesn't get like hot always in the same place. You just want to make sure your solder looks like a little volcano. That tells you you use the right amount and you don't have a cold solder. So now what I do, I hit like one, and the reason for this is mostly because then I can grab the board with my left hand and press the components against it, and so that it will be upright, because I don't like to see those components like all crooked after you solder them. And okay, that's the big resistor right there. That transistor that we just put in. In transistors, you gotta have the right speed. You don't want to be you don't want to sit there for too long because it can damage the transistor without knowing it. So there, and there. Now that okay. Now here's the double diodes. So I go one, the other, back to the one, to the other, the one, and the other, and that's done. Now, as I mentioned, some of them are already in good shape, but then like this one, I'm just gonna press it down a little bit. I see the resistor. This one, so it gets straightened up. This one. This little one. You don't want to press it without hitting with the iron because it can damage the pad. this one here. There. All right, so now let's finish it up. There. There. And the right way, the correct way, let me clean this up. And I try to be as consistent as I can with it. You put the iron in the pad and in the leg at the same time, like this. And then you hit the solder, not in the iron, hopefully in the leg or between the leg and the pad. Like you put it here, it warms it up, and then that way you get a beautiful solder. See? See? Here. And don't worry, because later I'm done, I'm going to clean it up with some ISO. And okay, you gotta make sure you don't forget anything, because if you do, things are not going to work, and then you don't know why. All right, so I hope, and it looks like I got all of them now. Let's just start cutting the leads. Transistors, I just leave a little bit in some cases for so that it dissipates heat to the bottom as well, especially the big resistor, this one. So if you look here, it is right there. You know, this I leave quite a bit of space here at the bottom. It helps to dissipate. Capacitors, they shouldn't get that hot anyways. Just make sure you account for the leads and they don't like hide in places that can cause trouble later. There. 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 Sometimes, depending on how much they stick out, I cut the diode. There you go. So, pretty much done, I would say. When you turn it back on, you always use a dim bulb tester, because it's not unusual for you to get things backwards, and a bright lamp will save you from further damage. All right, good. So that's it for now. So the moment of truth, as they say. Let me put this thing here close by, and let's I put a 150 watt on the DVT, and let's turn it on, and the lamp goes out. As you can see, we got 35 volts. Should be a little less. I'm gonna put it at 34 because we got a DVT on, so when we move it, it should go up. The relay clicked, and all seems to be good. I don't know if anyone
noticed beforehand, I had put this guy inverted, but I always do a visual inspection before turning anything on, and fortunately I caught it. But the TBT would just go bright and tell me that something is wrong, and so now I can safely reconnect the speaker post there, clean it up, and call it.